is Kerwin Stovall Williams. I'm going to try to organize my thoughts a little better. Okay, this is my theory of quantum gravity and how it can unite the field theory with special relativity, general relativity, Newtonian gravity, Euclidean geometry, so that everything is copacetic. Okie dokie, here we go. I was born the son of a schnow. Okay, all joking aside. Field theory currently utilizes an abstract form of notation. All right, so and it's always plotted. It's plotted on a two-dimensional plane or graph. So you got x and y, and then for the third dimension, the z-axis is introduced. And that's so that you can show three-dimensional objects on this graph. But what I'm trying to say is that where you're showing the three-dimensional object on the graph, I'm trying to state that I'm trying to show that the three-dimensional object on that graph is expressed topologically across the surface of that object or that dimension. The dimensions of that object are topologically represented three-dimensionally on a two-dimensional graph on a one-dimensional piece of paper. Okay, now the points on the graph are already set for it. Start at 0, and then as you venture out along the integer lines, they increase or decrease. The negative side of the integer line. They increase on the positive, and they decrease on the negative. And that is your x, your y, and your z. And it's all, moving away from that central point, that intersection. And that's all topological, that's surface area. When objects of dimension are volume, and that dimensional object that's represented of volume, literally it's of volume. So the space it's in it's of that, it's the object represented is of the volume of the space it's encased in or existing. Not only the space outside of the object, but the space in the object. All of that space is one summation of interference patterns, constructed and destructive. Now let's just take an everyday object. Let's take a square, for example, or let's make it easier, a sphere. And as our subject. Now that sphere has been so far defined by our human observation as a separate and distinct material. And that is not what I'm saying. What I'm saying is that that sphere is not separate and distinct. It is a part of a EM spectrum radial radial distance, diameter, radial diameter. Look at the radial diameter. And this is well outside the area of influence of whatever the sphere's gravity is. All right. Let's just take the empty space about this, around that, the sphere's in. So this is empty, and this is representing empty space. This is the sphere, right? Now, why is gravity on the most distal points of the radian of the area of influence negligible? Why does it decrease the further you, the further with distance? Why does gravity decrease with the distance from a source? It really, gravity does not decrease with distance. The source, what's being referred to as the source, the sphere, let's go from the center of that sphere. Let's unfold the amount of space that conglomerated to make this mass. Out here I said this is space, this is outside the gravitational influence of the sphere. I also stated that it is not outside the gravitational influence. It's just that the distal points beyond the midpoint, which is the center of the object, are the most fundamental fields that comprise it. The closer you get to the center of the gravitational influence, the more this negligible space has been folded and compounded. Up until the point you have a mass, a gravitational mass that can influence other gravitational masses. Mass is space. Okay, now let's pause that. Let's put a comma there and let's go to EV value. Now that is a notation that is used to describe how current influences electromagnetic waves. How when you introduce an introduction of a known value to an unknown value creates an equation. Well, it equates to an answer. And so if you don't know the value of the electronic impedance of an object, you can shock it and see how much of it cooked. And then when you see what comes out or what's left over, then you know how much